The quest for faster, more efficient travel has spanned centuries. From the early days of atmospheric railways to the more recent vision of the Hyperloop, this journey explores the ongoing pursuit to redefine the future of transportation. In 1810, an English inventor and engineer named George Medhurst proposed the idea of moving parcels and letters through tubes using compressed air. 2 years later, he shifted this idea to moving people along an iron roadway through tunnels. The original experimental carriages passing through the dark tunnels were windowless, causing much discomfort to those traveling inside. Not to mention the pressure difference was also a deterrent. Because of this, Medhurst reconfigured his design to allow the carriage to be outside of the tunnels, a theory that was later adopted as the atmospheric railway system. In its most basic terms, it can be described as powered by a tube of air, similar to a vacuum. With a piston running through a pipe located between the rails, air is sucked out of the tube by engines at pumping stations placed in intervals throughout the track. The fast-moving pressure causes the piston to pass through the tube. The piston is connected to a carriage by a rod that passed through a slot running the top length of the tube. This system was not without its difficulties, though. One main problem was creating an airtight seal between the rod and the open slot of the tube. Early iterations of an airtight solution involved a flap of leather between the rod and the pipe, known as the Clegg and Samuda patent, named after engineers Samuel Clegg and Joseph Samuda. The idea of using leather would eventually graduate to a rubber sealant after the conception of oil refineries in the mid-1800s. The atmospheric railway was virtually silent, achieving a speed of 28 miles per hour, and the ability to climb steep terrain, making it more favorable to the noisy and smoke-emitting steam locomotives that were commonly found in the English countryside. In fact, farmers whose land was located alongside the railways of the steam locomotives were worried that sparks from the track would set fire to their crops and frighten their livestock. Although the new atmospheric rail system had its positives, it was still met with much scrutiny. The overwhelming number of passengers meant that the tubes had to be considerably larger to handle the amount of pressure needed to transport the oversized carriages. This proved to be a costly issue, and maintenance was another series of problems. The leather straps used as seals would become brittle and crack over time. To keep the leather from drying out, tallow would be applied to the leather. However, the tallow attracted rats, who would chew on the leather, creating even bigger issues. The pumping stations also proved to be a headache. Each station needed to pump air out of the pipe and then back in as soon as the piston had passed through. But due to the amount of time needed to pump the air, deviations would occur and the system would come to a halt. While maintenance was occurring on the atmospheric railways, steam power locomotives were seen as more reliable and became the more favorable and cost-effective option. Fast forward to the 20th century, with electric and diesel-powered railway systems being the most prominent, only a few companies explored the atmospheric railway system further. One such company was Aeromoval, who developed a driverless atmospherically powered train that was mounted on an elevated hollow concrete box rather than a metal tube. Today, the company known as Aerome uses the Aeromoval technology for a passenger line of 2.7 kilometers at the Guarulhos Airport in São Paulo, Brazil. Flight Rail Corporation, out of Mendocino County, California, developed a prototype of high-speed rail system propelled by air pressure, known as VECTORR. As an alternative to current high-speed transit, the VECTORR was said to be affordable for passengers, offering many environmental benefits such as reduced noise, air, and earth pollution. Fewer tunnels would be required for the VECTORR line due to the train's ability to run on an elevated guideway. Unfortunately, the project has since been abandoned, but the concept and the question of what if still remains. High-speed transit systems have become an ideal way to travel long distances in a very short time. Maglev, or magnetic levitation, has proved to be a very reliable and efficient method of high-speed travel. However, an idea known as the Hyperloop has been gaining attention since the concept was popularized in 2013. A train that minimizes air resistance by using low-pressure tubes, the Hyperloop claims to operate at a higher speed than maglev. It also states to be more cost-effective and offer up to a 95% reduction in carbon emissions, though a lot of these claims are met with speculation. The Hyperloop also has a smaller passenger capacity than most high-speed trains, which means more pods would be traveling more frequently. While the atmospheric railway may have faded into obscurity, it is interesting to know the history of another means of travel. From early concepts centuries ago to the modern concepts of aeromoval and VECTORR, the atmospheric railway remains a curious technology.